Hello everyone, welcome back to ABI-DOS. Yesterday we did comparator and data size calculator. Spent, half an hour on the classic interview question that should take you about a minute and a half. Can you implement strlen? Well, it's a new language, give me a break. And not a language designed to be easy to do things in. Call Corrector. Who knows what that means? Let's try it out. This program reformats incorrectly dialed phone numbers, okay? X generates sequences of numbers that include a single hash symbol inserted at any position, followed by one or more ellipses. Sequences of numbers with a hash followed by ellipses, okay? Retrieve those sequences, adjust them so the hash symbol is at the end of each sequence, and then transmit them. So it explains here what I theorized yesterday is that blue wires are the same as red wires. It's like how Factorio has red and green circuits, or circuit wires, or whatever they call them, circuit connections. And they have exactly the same function. It's just a way for you to have wires cross over each other without touching. Kind of like, there's that early Zach game, Zachtronics game, Koitikotep or whatever, Engineer of the People, where you had like P silicon and S silicon or N silicon or something. I'm not a materials engineer, forgive me, I don't know what the right names are, but I think it was P and S. And they were the same, they were just like, no, they didn't. It's not that they were allowed to cross each other, they behave differently when you connect. They both could transmit a signal, but like when you have one used as a gate, the other, like one acts as and the other acts as or something, I don't know. And then he made, like, in the Zach, like, or no, Last Call BBS had a less atrocious version of that game that you could actually sort of play. I mean, it was playable, the original. It was just really hard. You needed to know a ton. Anyway, whatever. So they're just red wire and blue wire both transmit sensor data. They can cross each other instead of intersecting. Fine. Followed by a number of ellipses. This looks complicated. So you don't even know how many ellipses. Like, okay, yes, if you were counting, you could say, I expect as many ellipses as it would take to, be total length of 10 or whatever. I think you want an obstructor that holds hash signs. Ooh, here's a question. Is hash ever already at the end of one of our inputs? Not in this test input, right? Because if it were, you might have to be kind of careful. But my idea for now is when we receive a hash, we will just send it to an obstructor on infinite delay or indefinite delay. And then when we receive an ellipse, we will send a signal to the obstructor saying, release the hash that you are holding on to, right? Actually, the input description says the single hash symbol inserted at any position. Well, it could mean at the end. It just isn't in any of the examples. I guess I can look at later test cases. I still don't see it in any of these being at the end. So I think it's reasonable to say that we're not supposed to handle correctly dialed phone numbers, only incorrectly dialed, meaning the hash isn't at the end. I think that's okay. Okay. No new gadgets are suggested to me for this puzzle, it looks like. So I think if we get, like, we want, I think, first, like, let's test. I think I want to test if it's blue first. I don't need to duplicate it if it's blue. Well, thing is, this is hurting my throughput. Everything I do that isn't part. Okay, I guess I can do like this, right? So if it is blue, okay, request another bit here or something. So we have a gap of 1 in between each thing. Maybe I just can't afford to ask for input at an unspecified time, which I kind of hate, but... So only if you are blue will you be sent down here, is what making it inactive by default means. Non-blues will continue on. I want another color sensor. Oh, actually, we don't have to do these in series, do we? Excuse me, drop something. We could make a duplicate of the input and then run it through both the blue and red testers. Oh, but the problem... Is there a problem? Maybe not. That's interesting. Because we could basically say, like, let's make 3 copies of the input bit. And test to see, is it neutral, is it blue, and is it red? If it's blue, we'll send a signal to release any held thingies, any hashes. And that's all we'll do. We'll of course unconditionally request a new U-bit. But if it's blue, we just need to release the hash. If it's red, we need to route it into the obstructor. And if it's white, we need to output it, and that's it. As long as we can make sure the whites and the reds don't get mixed up, which means ensuring they both have a similar length path to the exit, I think. Okay. So what if... we did something like this? There's not like a rotate or something, is there? I've looked before and there still isn't. Yeah, okay. Oh, you can mirror junctions. What? That's news to me. So if I have something like this, what button is it? Double L or press Q. So I can actually make a qubit want to turn left from here instead of wanting to go right. I see. Okay, that's interesting. So that's why they're rendering this way. It's not just as a reminder that's what qubits want to do, because you can actually override that behavior. All right. So now I could put a little thing on each of these testing, are you blue, are you red, are you neutral? I'm not sure I could actually afford to ask for an input here, though. Yeah, that's way too fast for this approach. I'll put it here, and I'm just not going to worry about speed at the moment. I'm just trying to understand this stupid algorithm. In fact, we probably can do a little better by having the blue detector just immediately here send a signal somewhere and then recycle itself. Well, we still need an input. Oh, right. The issue is... oh, there's so little space. So the default state, I guess, should be off. And then when it's on, it can go down here. So if it detected that it was blue, well, actually, I don't need a conveyor, right? Because this copy, I have 3 copies of the input. This one is never going to the output. If it's blue, I send a signal. And if it's not blue, if it's blue, I send a signal, then throw it away. If it's not blue, I just throw it away. So can't I just do this? But also, like, send a signal out? I think so. So I think it can actually just look like this. have another color sensor here for, I think, red is appropriate. And if it needs a conveyor of this sort. Right. So if it isn't... if this detects red, then this will become inactive and we'll go here. Which is what I want. So if we detect a red, we turn off this conveyor so that we get the red here. I obviously haven't drawn in the wires yet, but I don't think I need blue. I think I don't think I need blue. Well, it would save me a little space, I suppose, to use blue wire. And I guess it's kind of nicely thematic that the blue detector... Oh, it even lights up what it's connected to. That's kind of neat. Huh. Okay. I don't know why this... Oh, I can't route it through this other detector. I see. That's why that's a bad idea. No, I don't want to route it through this either. It actually does have to do something like this, which means it might as well be red. And anything... if it's neutral... we need to be a little careful, don't we? With when we request new input. Because I just said I threw away the blue. So if I get a blue input, I'm throwing it away and never asking for a new one. And if there was a red one trapped, that's fine. Because the red one is asking for a new input on its way out, but... I think we could say that whites and blues should always request a new input, but reds actually shouldn't, right? And that way we get... Well, no. Reds should request one before they enter sequestration, actually. So we need... Well... Alright, let's leave that out for now. We need something like that. So if we detect a white... I want to turn this conveyor off and go this way. It defaults to on, which is just to recycle anything that isn't white that comes through this little segment. that. And now I think I just have the problem that blues are not requesting a new input. Yeah, doing it this way seems way easier than trying to it's way slower because I'm only requesting a new bit every 4 to 5 to 6 cycles or whatever, as opposed to every 2 cycles, which I think I could maybe, I don't know, but orchestrating all that is much harder. So how do I do that? I sense a blue. If it is not blue, so I think I can put a conveyor here. And it's already connected to what I want, so that's great. It's already connected to this. If I sense blue, I want the conveyor to be on. Because non-blues should just be thrown away, whereas blues should request an input and then be thrown away. So I think I want this one inactive by default, turned on only when it sees a blue. Like this. It doesn't look like the prettiest thing anyone's ever made. This whole making 3 copies and just having 3 independent branches going at the same time, I'm not really sure if that's a cool way to do things or just a stupid way. So okay, if we get a neutral, we turn off this, so we aren't throwing it away. Instead, we're requesting it and outputting it. Oh, I guess we can do a bit better here. If we detect a red, we're turning off this conveyor so it doesn't just get thrown away. Instead, we ask for a new input and then hang on to this one. If we detect a blue, we're turning on this conveyor so that we get an input first before getting thrown away. Okay, let's see what it does. Nope, wrong already. Really? That 4 was supposed to go here. Do I have all of these backward? I don't know. So, oh, I didn't connect these 2 with red wire. Oops. Try again. So this just became inactive, which means it's going to go here and get output, right? We ask for a new input. We throw away the red and blue versions of the EU bit. Same thing happens. It's the same number, a 4. Then we get a red hash. Should get thrown away here and here, but here it should... Yeah, this just got turned off, meaning it's going to go here, ask for a new input, and then go into hiding. Now we output the 2, we output the 3, we output the 1, and a 4, very long phone number. A blue comes by. This is going to get thrown away. This is going to get thrown away. But we detected it was blue, so we output the hash. And then we threw these both away and got a new input. Looking good. And then we're starting over. Yeah, I think this is done. Yeah, not bad. I mean, it's gonna be pretty bad on everything, I imagine. Oh, yeah. Okay, I mean, better than 24% of the population for cycles? That's better than I expected. Yeah, I mean, I don't know. This... Oops. Not this one. I didn't expect this to be efficient, but it seems... nice? I guess I'm not qualified to say that because I don't know what a different solution would look like. I mean, I kind of do, right? You would test in series, kind of like, is this blue? If so, do something. Oh, was it red instead? If so, do something. So I don't know, but I kind of like this. It seems easier to think about than doing it the other way. Pairer generates value pairs, each consisting of either 2 letters or a letter and a number. Okay, but as far as I care about, those are just numbers. Oh, maybe it asks me to care about the difference? Read X and Y as pairs. If either is a letter, letters are values greater than 99. Okay. Well, not all of them, because for example, like 181 is a pixel or something, or 180. And, right? Like, ellipses were, I don't know. Either is a letter. What? Oh, send them both to S5. I thought it said send it to S1 and S5, and I couldn't understand that. No. Send 0 and 1 to 5 in that order. Ah, this is explaining to me some confusing behavior I saw. And also some tooltips that I didn't know what to make of, this OE. So order of execution. Okay, so maybe this understanding might help me take some of my 2-cycle throughput solutions and turn them into 1 cycle if I could understand it better. So first, U-bit collisions are processed at the start of a tick. So like 2 U-bits that are already colliding on the same tile get merged. Then the resulting U-bits interact with the icons that are there in execution order. And so each kind of icon describes, like, tells you what order it's going to go in. Oh, this seems inelegant. Maybe there's a reason. I don't know. Okay, and if there are ties, then it matters, like, how... where things, if there's like 2 different colorizers or whatever, then they're triggered in order based on where they are on the grid. If 2 icons with different order of execution are triggered simultaneously. What? Okay, so triggered not as like if they both try to produce a trigger signal, not if they both receive a trigger signal. Although maybe... really is column major, huh? Okay. So the highest OE, i.e. the one that comes last, yeah, will actually take effect. Okay. Interesting. So this sensor we were looking at, like this one is OE20 or whatever. Conveyors are also OE20. What about the writer I was using? It's like 4 to 7, very early. Was it Sifter where I... Yeah, but the other save file, please. Here, this is an example where I was kind of having problems where I wanted... Well, I don't know, this doesn't tell me anything. I don't know how I would use this information to make this go better. Yeah, forget it. I'm out of here. Okay, back to... Nope, we just did Call Corrector. To Pairer. I'll put them in order, otherwise it said throw them away? Yeah. So disregard, sure. Although, wait a minute, I don't understand what this means still. They're triggered simultaneously. I guess that's true. These guys send a signal whenever they see a U-bit. And the signal is either go to state B or go to state A. It's not like do nothing. So, okay. I can't just have two different sensors wired up to the same set of conveyors. Because, like, the bottom one will win, for example. But I can have two sets of conveyors, each wired up to a different sensor. Right? That seems promising. And actually a throughput of 1 U-bit every 2 cycles is actually the best you can do on this puzzle. Because you're getting input twice as fast. Like if you consume an input every tick, you'd have to produce 2 outputs every tick, which is impossible. So actually 1 input every 2 ticks is the fastest you could possibly be, I think. Which means I can afford to, like, duplicate each of my signals so that they each have, like, a copy of them to trigger sensors for them, right? imagine something like this. This? Not sure. Where you put a greater sensor like here. Well, I need to request a new input at some, like, on one of these at some point. One of these four has to be requesting input, which means I don't think it can. Yes, one of these can request a new input. Because I'm only using. I only want to trigger. I only want a sensor for one of these. So let's make this a sensor. Links 0? Oh, you're just saying it's not connected or something? There's nothing to, I guess. I don't know. Greater than 99, I think it said, right? So if this value is greater than 90, no, I actually want to do it the other way around. If it's less than 100, I want to throw them away. I want to throw them both away. Something like this, right? Where these are all connected. So the U bits from the input will be standing here the same time something's standing here. They'll both be pushed up instead of their natural direction, right. And then this one won't necessarily, well, I guess it will still be on, which is fine, I guess. But even if it were a single tick of on, it would be fine, because this U-bit would now naturally want to go to the recycler, as long as something didn't push it in another direction. And then we're going to do a similar thing here. Feeding to a recycler here. Zero and then 1, is that correct? Yeah. Like so. And I'm not sure about whether these need to be default active or default inactive. We'll get there in a sec. Okay, so if the value is less than 100, we want these to be thrown away, which means this conveyor needs to be on when this tells it to go to state B. So state A must be inactive for all of these. Does this make any sense? Let's see. I think I've done this backward already. It's stupid. I'm throwing it. This is wrong. We haven't even done anything with the results of the comparators, and I'm now just thinking through more clearly. I don't want to throw it away if either of them is less. I want to throw it away if both of them are less. Because now I'm going to throw both of these. Oh, no, wait. Yeah. Because now I'm going to throw this away based just on the comparison by 22, which which is incorrect. I should look at whether the other one was big enough before I decide to throw it away. Yeah. So this is sort of backward, actually. I should be saying if either of them is greater than 99, send them up into a path where I'll be willing to output them, basically, right? And if neither of these sets of conveyors manages to divert them, then throw them away. So it shouldn't necessarily be a recycler there. I want that on, I want that off. Okay. So if it's greater than 99, one of these two things should send it up. And otherwise, we should recycle it. Neither attempt to, yeah. And I think we can just do this. Whichever route they take to get here, the one from 0 will arrive here first. It'll either go like this, or it'll go like this. But they'll both go along the same path, and the one on 1 will be further away. And it shouldn't overlap with anything from a subsequent signal, right? Because they're off by 2. Yeah, I think this is fine. What happens now? So now they won't be diverted, and then they won't be diverted again. Now, let's see, this one won't divert. This one will divert and will output 50105, right? Great. And then we'll divert here, the 102 and the 8. Yep. Looking good. Oops. Just push. Great. Yeah, I actually like that a lot. Let's see how we come out in a moment. The machine is evolving. The data streams are flowing more freely now. I can see patterns, connections that were once obscured. Your efforts are not just building our computer, they're building something greater. Yeah, error, data breach. Okay. These are different bits than the last time we got something. Right, this is 9, which is I? Yeah, I is 9. And this is 19, which is S. It says SI. Although this bit here, I think is weird. You wouldn't normally see that in ASCII, I think. How are we for time? Less than an hour, but it's been a bit. And did we do just one thing? No, we did Call Corrector and Pairer. Yes, that's right. Oh, maybe I should put those in the titles. I like making up silly titles. But maybe I should be putting... It's better for SEO, right? People will search for a puzzle name and the game name and find the video. Okay, so how are we doing though performance-wise? We're not going to do another puzzle, but let's see. So cycles, as good as you can do, indeed, as I predicted. Icons kind of in the middle. Space, better than average, weirdly. A little worse than average on icons. So people are doing this. Well, yeah, of course, I think. Yeah, if you wanted fewer icons, I don't think you need these duplicators, really. Because we have a cycle length or a periodicity of 2. Also, we don't need so many recyclers. Obviously, we could just route all of them to the same place if we were willing to give up space by like routing, long paths. So I think we could do this with 4 fewer icons, probably. If each bit just had its own, like if these were just, yeah, in fact, I mean, oh, let's make this a separate solution though. Instead of duplicating, if I just did this. Yeah, this is gonna hurt my throughput though, isn't it? No, just latency a little. So if this connected to here, we scoot that over a bit. And then this connects to these. Like so, right? What does this do? Does this make any... Oh, this is coming a little too soon now, huh? Because now I'm requesting input every tick, which I can't afford. Just shift the whole thing over. I don't know. It's even worse for space, but it doesn't cost me any icons or any throughput. And I guess having the port here, as opposed to here, do we care about worst case time or best case time? I think worst case, maybe. Average case, like, it doesn't matter where I put it, I think. Anyway, so does this still make sense? Uh-oh. Oh no, this is fine? Yeah. So we're still outputting 1 bit every tick. And there's... Wait a minute. I stopped here? Oh, right. We're only outputting 1 bit every tick if the incoming data is data that should be output. Of course, if for data we're supposed to drop, we're spending 2 ticks dropping data, basically. I guess you could go a little bit faster. If well, how could you? If you determine, I'm not going to try to implement this. I don't even know the details of how you would make it work. But it seems as though you could have data like waiting in a queue to be released and only let it out when like the port is ready for it. Like if you asked for input 1 bit per tick, like every single tick asked for input, but like only until your queue was full or something. You could have a queue of inputs ready to go, and when you detect, hey, this cycle, I'm not actually outputting something, output something from the queue instead. Yeah, I mean, that sounds quite ambitious, but I think it's not the case that this is as fast as you can possibly go. In the steady, if every input is suitable to be output, you can't go any faster than this. But because some of them, in fact, are not suitable to be output and should be dropped, you could consume input faster so that you have a buffer of output ready to go when some undesirable input is encountered. So, okay, that's interesting. And this is a solution that's better on icons, and I guess better on space as well. Now we're in a better spot. And actually, that's kind of interesting. We're actually... It's just as good on cycles, so yeah, I guess that idea of duplicating things was sort of unnecessary, wasn't it? Right. So the reason that duplicating something was a good idea, like duplicating something in order to have a U-bit trigger its own conveyor, that was useful to get the throughput down, or up, I guess, to 1 per tick. But since we can't afford 1 per tick anyway, and 2 per tick is the fastest we can go, we just never needed to duplicate anything to begin with. Huh. We could actually shave a tiny bit of space without any rerouting here. Like this, couldn't we? Doop. Right? So when a U-bit gets diverted up this way, it should pass through the port unharmed, right? And turn right? Nope, it turned... Ah, because we requested an input at the same time. I see. Right, so when this requests an input, there'll be a problem. I was just thinking, hey, couldn't we reuse this? When a bit comes up here, it'll turn right, and the spawn bits will... Yeah, but that doesn't work. Because there might be bits there at the same time. The pathing would be right if things were spaced out, but they're not. Actually, I want to test something before we go. What happens if U-bits kind of pass like ships in the night? Green segments don't count. Yeah, okay. So... Can I have 2 of these or still no? So can I write, like I can't, it just says it's always 0. I thought it would be, what is, I don't know what clicking in here has accomplished. I've made some of the squares lit up. Okay, weird. Oh, I think it said something about this being a breakpoint. Like, I misunderstood what it meant. I think I'm setting breakpoints this way, saying when we get to this bit, like pause. Breakpoint 7, yeah, I see. So what I wanted to do though is test what happens. Why is this, am I like that bad at clicking? That one's always, I guess there's just always a breakpoint at the beginning of the program, kind of. Makes sense, I guess. Where's my thing that writes a 0 to begin with? It's around here somewhere. Port X? Yeah, spawns a neutral U-bit. So I want to do something like... this. Let's set this equal to 5. And I have another one, this is 10. And just have them pass by each other. What happens? So they're not going to be in the same space. They're not colliding. They're moving through each other. I predict we'll get 5 here and 10 here. Yeah, they go through each other. Okay, interesting. The other thing I wanted to test is what happens with colors. It said red and blue is magenta, but what's like magenta and blue? How do those behave? If I just add blue to something 10 times, does it get bluer? Like, what's the deal? Let's make that red. And that's blue. But move them closer so they collide. Well, yeah. And what I want is a duplicator. Like this, I guess. And I don't know, you go out and you get thrown away. So okay, we didn't need to duplicate there, but and let's define this to be a pixel. It's 180 as I recall. So red and blue are mixing. They're becoming magenta. We mix in some more blue. It seems like it's staying magenta, right? It's not getting bluer. So 181, what's the pixel value? Did I forget? I don't know. I don't remember what it is. It doesn't seem to be outputting the way I wanted. But the color didn't seem to change. We added blue to magenta, and it was just still magenta, right? Yeah, it's very much the same color. Weird. Huh. And if I added green to it? So that's magenta. Now we'll add green. It becomes white? Gray. Okay. Interesting. All right. Well, I mean, just playing around with some stuff, I guess. But no new puzzles today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.